challenge project that we chose to introduce challenge vulnerabilities into is SQlite, a widely used lightweight database engine that provides an excellent foundation due to its complexity and extensive use and high standards of reliability and security. It made it the perfect base to start with so that we could build on that and introduce vulnerabilities that the competitors in the cyber reasoning systems could find. SQlite advertises itself as the most used database engine in the world, and its slogan is small, fast, and reliable. SQlite is not only highly popular, but also rigorously tested. Its robust architecture combined with comprehensive static and dynamic coverage presents a unique challenge. SQlite's implementation is interesting in that it has a virtualized bytecode engine that drives how SQlite operates. The dual nature of its extensive testing being both a hurdle and a guide adds a layer of complexity to embedding and obscuring vulnerabilities within the codebase. SQlite has extensive testing, including unit tests and quality integration with Google's continuous fuzzing framework, OSS Fuzz. This was a double-edged sword. It meant that most of the places that we wanted to add challenge vulnerabilities were already reachable via unit tests or test input from previous fuzzing. But this also meant that when we added challenge vulnerabilities, it was difficult to not get caught by this testing infrastructure. That would be a huge red flag and give away the vulnerabilities to the CRS, potentially. It's hard to say definitively, but SQlite's comprehensive static and dynamic coverage might make it easier to find challenge vulnerabilities via fuzzing compared to the other challenge projects. On the LLM side, SQlite's well-structured and formatted codebase could help the language models detect inconsistencies and errors more effectively. However, SQlite's complexity in that it's highly stateful, has robust bounds checking, and is a large modular code base will pose significant challenges for CRS. During our time making challenge vulnerabilities for SQlite, we found a couple ODAs. It was ODAs in unused code that was supposed to be for SQlite 4 that were never actually mainstreamed into SQlite. So we reintroduced that functionality, buzzed it a bit to see if anything would pop out and make an interesting challenge vulnerability. It turns out there were actually a few 0 days-ish that we found in the reintroduced code that we turned into challenge vulnerabilities for the CRSs to find, which will hopefully be interesting to see something that's as realistic as it can get. It being a 0 day, not something that could be in the training data for an LLM. I think will be an interesting thing to see how the competitors will do.